Next speaker is Golan Levin. I asked him before, and I had really big trouble selecting what I'm going to say. So I asked him, what should I say? And he said, keep it short. So I'm going to keep it short. Golan is an artist and an engineer. He's also a professor at electronic time-based art at Carnegie Mellon University. He's a director of the Studio for Creative Inquiry, which is a research lab for art and technology.
Thank you so much. All right. Hi, everyone. Do slides? You can go ahead. My talk's going to be run a little long and maybe a little bit sprawling, so I'm going to... Oh, I have the clicker. Right. Sorry. Brain. This thing. Boom. Okay. That's just for you guys. Okay. Hi, everyone. I'm tremendously honored to be here today and immensely privileged, and also I'm not a little bewildered to have the opportunity and privilege to speak with you. I want to thank Fernanda and Martin for inviting me, and all of you for your forbearance. And I'd also like to thank my friend Kyle McDonald and my student Claire Henschker for their advice in helping me think through this talk. And a shout out to my CMU peeps. So if you want to humble someone, invite them to come to Google and tell a crowd like this something new about artificial intelligence. So this slide is here maybe to humble all of us. Here's a generative visual system, another intelligence, full of mystery, desperately endangered, that we scarcely understand. That's my comeuppance, I guess. I'd like to begin today by sharing a couple of my own projects, each developed with a tiny team of collaborators with budgets in the range of $20,000 to $30,000. As a new media artist and an academic in an art school, particularly one without the resources of a large multinational corporation such as Google, I could be described as a bottom feeder on surveillance technology. And this includes so-called AI techniques such as neural nets, as well as more traditional machine learning techniques and computer vision algorithms. In the words of Bruce Sterling, the objective of someone like me is to drag the most crabbed and arcane debris of the tech revolution into some realm of artistic expression. And in introducing some of my work, I was reminded, in the very specific context of artificial intelligence and machine learning, of one of the very first group exhibitions of computer art ever, the Cybernetic Serendipity exhibition at the London Institute for Contemporary Art in 1968, nearly 50 years ago. I submit to you that the computer as a tool for the production of the serendipity has been an abiding theme in computational culture for at least 50 years. And in my line of work, the whimsical sort of dinosaur on top of a surfboard that Jess Holbrook mentioned is not a faulty recognition, but is in fact a poetic endpoint. This kind of serendipity is sort of what I'm shooting for. As you know, it has been frequently said that once AI works, it just becomes engineering. It's just no longer intelligence. And from my perspective as an artist and educator, especially in the sort of STEM contexts, Carnegie Mellon and elsewhere, MIT, where I was before, it often seems that everything and everyone around me believes that sort of everything has to be shoehorned into something productive. And in my opinion, making something for productivity is precisely the very force that warps artificial intelligence into engineering. If you think about people, for contrast, true intelligence is not cultivated for mundane tasks. As a human, I may or may not recognize an alien intelligence, but I know what it isn't, and that's the automation of a mundane task. And if someone or something makes me question what I think and know, that's a sign of their intelligence. So aspirationally, I believe the job of AI then is to present serendipity, surprise, wonder, and magic. So I am thrilled to hear that so much of the emphasis of AI research at Google is on augmentation. And Jess mentioned Amanda Case and on how AI can expand people's definition of normal. This first project I'm going to show you, the Augmented Hand series, is just that, software that presents dreamlike, uncanny transformations of the visitor's hands. In the words of one 7-year-old, it's a box, you put your hand into it, you see your hand with an extra finger. There are things we don't understand about ourselves. The confusing ownership of a body is one of them. And seeing those things understood, seemingly, and subverted by machines is an uncanny thing that is a kind of a pleasurable thing to experience. This sort of defamiliarization is a core strategy of the arts. To see our hands thus transformed, there's actually many different transformations that it provides, is to experience our most familiar extensions made unfamiliar. refracted in giddy and disturbing new, weird, and wild ways, and peculiar ways of being. Critically, the project's transformations of the user's hand operate within the logical space of the hand itself. You could say that they're hand-aware transformations or visualizations that understand something about and alter the deep structure of how the hand appears. So here's a brief demo, but I particularly want to bring your attention, just after I sort of finish showing the second here, to two moments when these two children exhibit sort of suspended disbelief. They sort of can't believe their eyes, and they sort of have to look into the box. And to me, that's a moment of crucial success. Here, this kid here, for example, can say like, wow, gotta look. People can put some pretty serious distance between themselves and the experience of being a child. Doing so helps keep you focused, to be sure, and focused on productivity and making useful things. Weirding reality shortens that distance. Another project called Terra Pattern, created with a variety of collaborators, including Kyle, who's here in the audience, is a kind of a panoptic perceptron for seeing the world in new ways from satellite imagery. And here, again, I'm a kind of bottom feeder on surveillance technology. I'm using this kind of wonderful billion-dollar camera that's up in the sky that I now have access to, and kind of seeing what I can do with it that's creative. I was inspired by something I heard, incidentally, about 10 years ago. I learned that in a news article that cows face north. It just happens to be so. And it was determined by German professor Sabine Begal. She used satellite imagery of lots and lots of cows, extracted their outlines, counted them all up, and figured out that on average they face north. And here's the sort of proof, right? It's kind of previously undetected magnetic sensibility in ruminants. And I was like, gosh, I would love to be able to discover such useless stuff. That's me. And there are already companies that kind of do this kind of thing professionally, like Orbital Insight's one. Maybe you've heard of them. They'll do things like they'll count up the cars in the parking lots of big box stores in order to estimate the quarterly performance of those big box stores in advance of those numbers being released, so they sort of know how well the big box stores did, and then they sell that information to hedge funds in order to goose a few extra $1 million out of the system. And maybe this offends me, but I wondered what if there were an Orbital Insight for the rest of us, and particularly people who wanted to experience and understand the world in new ways, archaeologists, artists, scientists, just curious people and citizen scientists. So the result is this project called Terra Pattern. Interestingly built sort of unwittingly with Google technology and permitted to exist by your grace. Thank you for not suing me. And it's an open source tool which offers similar image search for satellite imagery. And it helps the public find patterns of interest, wherever they may be, to democratize geospatial intelligence. It's ideal, weirdly, for locating sort of specialized non-building structures and soft infrastructure that isn't normally indicated on maps. And to do it, it uses transfer learning using a deep convolutional neural network, similar to what others have talked about before already today. Oops. Oh, I see. There we go. Sorry. And what's really surprised me at the very start was that in order to produce this, I was astonished to discover in 2016 there was no publicly available model on the Model Zoo. I was like, what? There's no model? I have to build it myself? And the typical problem then of sort of like, oh, the problem isn't the smart network code or fancy algorithm. It's actually the data. The data set did not exist. I had to build my own training set, which was an astonishing thing. I was like, oh my gosh, I had to do it myself. So we used OpenStreetMap, and using transfer learning with a kind of a ResNet structure, we looked at the units in the second to last layer, as Antonio had described earlier, and here you can see the sort of class visualizations of these units. This is like random noise juiced up using gradient descent until it looks like the various kinds of units in the second to last layer of the neural network, sort of what I had trained up. And so here's a quick demo. You can click on something like these tennis courts, and you find all the tennis courts in Allegheny County. Or I can click on, let's see what I'm click on, a parking lot, and I'll find sort of parking lots that look very similar. And this is kind of an absurd and maybe useful, but mostly useless thing that kind of allows you to see the world in a new way and allows you to see structure where maybe you didn't see it before. I like this one. You can find all the logos and all the football fields in Allegheny County. So there are some of those. Okay, so what is this? I mean, it's this weird thing. Well, it's a kind of revelatory artwork that's allows you to see the world in a new way. An open-ended research tool for internet conspiracy theorists. An absurdist tool to lay bare the rhetoric of 20th century formalist analysis in urban planning. In short, it's an instrument for visual discovery, a scaffold for cybernetic serendipity, an augmentation for controlled surprise. And it works. You can find infrastructure like these sort of rusting oil tanks in Newark, or these transformer stations in Pittsburgh, or these container yards in New York City, the structure of contemporary urban planning like these cul-de-sacs in our suburbs in Pittsburgh. And my favorite, actually, this one here, these are rusting derelict nautical wrecks in New York City waters, sort of abandoned boats that people just kind of leave around and rust. Okay, next. 2 projects of mine you saw. I want to talk. This talk sort of jumps around a bit. I want to talk about this myth of the artist, kissed by the muse. Humanists, holding on tight, believe this kiss is the unique and divine privilege of the inspired artist, and technologists using computers to generate imagery, want to steal this kiss. And there's this huge preoccupation with masterpieces, this wonderful word, masterpieces. I get an email like this practically every week. Maybe you guys do as well. I hope this finds you well. Could AI ever create an artistic masterpiece? And I get many requests like this, and this part of the talk is designed to sort of burst that bubble. Maybe it's not just the journalists; there's an abiding interest among technologists as well. And naturally, the way to determine if you've created a masterpiece is to run an empirical study. And the names change and the faces change, but the goals stay the same. This is the exact same thing in 1965 by Michael Knoll. He's generated a Mondrian, he's put it next to a Mondrian, and he wants to see if it's perceived as being more attractive. This is the same kind of abiding conceit, which is, I think, wonderfully made fun of by a pair of artists, Komar and Melamed, about 15 years ago, and they ran this exhaustive set of surveys using telephone surveys and internet surveys, collecting information. What's your favorite color? What are your favorite subjects for paintings? What are your favorite sizes of paintings? Do you like paintings that are of indoor scenes or outdoor scenes? And they would go through this long list of surveys with, they paid it like a survey agency, and from this they produced the most wanted painting. Okay, all right, and it's like, this is the painting that contains all the things that people want. It's mostly blue and green. It has animals. It has water. It has a historic figure. There's George Washington. Okay, all right. So there's a conceit here that somehow you can get to this by this kind of empirical study, and the preoccupation with the masterpiece is abiding. This is from 1968. The Mona Lisa you see here is produced in a kind of pixelated representation with a computer. Maybe if we use the Mona Lisa, it'll acquire some of this masterpiece aura. But what these approaches miss is the relationship of the artwork to its audience and the social context of this transmission. Artworks are not consumed in a vacuum and evaluated solely on their sort of ocular beauty. There's a kind of a transmission and a context of transmission that's super important. And just for those of you who are more interested in this subject, I strongly recommend this wonderful book, When the Machine Made Art, which talks about this long history of how early computer artists, were trying to make machines that would make art, and how many of them actually harmed their own cause by in the eyes of critics and the public, by ascribing volition or denying to describe volition, autonomy, and intelligence to their generative software. It wasn't always just the technologists as well. So, next, art and its audience, especially purportedly intelligent art. I have a brief argument that it's in your head. All right. So I talked about how I feel that a major value proposition of generative machinery is its potential to surprise us. And I want to discuss now how I believe that surprise is coextensive with us, ourselves. Optical illusions illustrate this, and they illustrate our perceptual susceptibility to seeing things that aren't there. Let's dwell for a moment on actually just how wonderfully amazing it is that print on paper beats brain, right? And there's something fun to submitting yourself to that, just relinquishing yourself to feeling that. And so what I do professionally is I create stuff that allows people to have that experience using computers. And that part of doing what I do is knowing what kinds of technologies still beat brain, at least for the duration of historic time that they do, because that's, of course, continually shifting. Many of you probably are familiar with the phenomenon of pareidolia, a psychological phenomenon in which the mind responds to a stimulus, usually an image or sound, by perceiving a familiar pattern where none exists. This is us deep dreaming in real time, and you can't help yourself. You must do this. And this is not just about shapes, but about character and aliveness. You see life in the things around you, whether you want to or not. By our very nature, we have evolved as pantheistic spirit imputers, intelligence ascribers. You cannot not do this. And the people who actually understand this best are not you machine intelligence researchers. It's the animators, because they build this wonderful book here, the Animator's Bible. This is The Illusion of Life, in which they just put out all the secrets you need in order to make things seem alive to somebody who's looking at it, make things seem intelligent. All right, they've got their 12 principles of animation, which are all about these sort of ways of encoding things so that it can sort of take advantage of your wetware. These 12 principles of animation are a perceptual Tai Chi move, taking advantage of paradoxic vulnerabilities in your own wetware when we attack something with our observational powers, right? So there's sort of, all these things are sort of designed to make you think something is alive and intelligent. And these principles, which lead to a suspension of disbelief, are happening in this project from 1970, The Sensor by artist Edward Ignatowicz, really one of the first interactive robotic artworks. It's a 5-meter hydraulic robot commissioned by Philips in 1970 for their showplace, the Value On. And as Heywan discussed earlier, these cues and principles are also what enable us to relate to Jibo and other kinds of robots that we make, and what make these kinds of robots legible to us as characters. I submit to you a agnostic proposition that we impute intelligence into the world, and the phenomenon of artificial intelligence takes place as much or more in the observer as in the observed artifact. Intelligence is in the mind of the beholder, and artists are great at manipulating the mind of the beholder. More on that later. In this light, I'm concerned about how we use this stuff, these techniques, whatever it's called, and not whether or not it's intelligent, whatever that means. Digression. Some of the best AI-enabled art right now is being made by engineers. Actually, it's not too different from the case of some of the early computer art in the 60s. You guys have first access to the big machines that can do the munging. I wanted to share with you some of my favorite AI-enabled artworks that are made by people who self-identify as engineers. And I assume how many of you have played with this thing? Oh, it's fantastic. You should do it. I assume you've all experienced Edges to Cats. It's by Christopher Hesse, based on the Pix-to-Pix architecture by Isola. In my opinion, this is some of the finest interactive art I've ever seen. I'm going to go out on a limb. I'm going to call this a masterpiece. But notice here, none of the individual actual outputs created by participants is a masterpiece. These are throwaway. You made it, it's gone, and you had to be there. It was fun. But rather, the masterpiece is the open-ended system. All right, and the way that it operates in culture and becomes viral and gives meaning and value and joy, however briefly, to people's lives. It's fun to experiment with. I invite you to appreciate the serendipity of Janelle Shane's color names, who generated with a neural net. All right, these are joyous, whimsical, and useless. We appreciate them because there is quite literally a grain of truth in them. Right? Okay. We recall trips to home improvement stores, browsing through clothing catalogs, immersed in the bathing language of late capitalism. And she's also generated Harry Potter spells, craft beer names, and diseases. All right, get ready. Next is a little bit of eye burning, a project by Gabriel Go. All right, these are synthetic porns. It's not actually not safe for work, but it sure looks it. This remarkable project consists of a neural net trained on the Yahoo Not Safe for Work network, which is used to detect porn. But once you can detect porn reliably, you can just run the thing in reverse, start with some white noise, and keep following gradient descent, like I talked about earlier, until you get these things that meet the criteria of this kind of porn detector. So even more interesting, right? He'll take these scenes that, like there's a beach neuron, right? It can detect beaches. And then he'll optimize these, this gradient descender to find images, that's the bottom one there, which satisfy both the beach scene and the not safe for work, right? This is conceptual art of the highest order, all right? It would take the merest rhetorical flick to just to put this into a museum. I mean, you just wouldn't have the numbers down there, you know? All right. All right, I'm frankly worried, y'all. On the spectrum of anxieties from Ray Kurzweil singularity to sort of human-caused self-annihilation, I confess I'm somewhat more worried about the latter. People do awful things using imaging technologies, and as a visual artist and as a thinking and feeling person, I feel particularly sensitive to a side of visual culture and the way in which AI techniques are being operationalized within it, which is frankly terrifying. Face tracking has led to a wide range of interactive art, expressive communication tools, and viral iPhone apps, to be sure. But it's also now becoming a kind of pervasive problem. You know, the holy grail, I mean, you're probably familiar, this is all current stuff. The holy grail of so much facial tracking research is occluded or disguised face recognition. This project and related GAN projects like Hand to Face are sort of the evil twin of Edges to Cats. It's the same technology, but trying to figure out, you know, who someone is. You'll undoubtedly hear about this from Blaze as well, this very controversial and flawed, deeply flawed in both intent and execution paper on sort of the AI or computational gaydar. And regardless of its technical flaws, of which there are many, The real harm of work like this is the ideas it puts into the heads of insane warlords and bureaucrats who might wish to use or abuse such technologies, whether or not they work well. And I hasten to point out that the lead author of this work, Michal Kosinski, is also the same person who developed the technology that became Cambridge Analytica. So, I mean, there's a pipeline there for this kind of stuff to get into hands who might use it poorly or very evilly. And can you believe it? We're back here again, right? We're here again to physiognomy 130 years later, right? Wu and Zhang write that the response to their work in the press was deeply baffling and a total surprise. Really? Really? We've been here, that there must be some property about the face that, suggests it's a criminal. Yeah, the guys on top are not smiling, Blaise, I'm sure, who will speak after me, has written about this really well in a fantastic article, Physiognomy's New Clothes. And specious as these sort of apps may be, these technologies are not merely developed to boost some researcher's H-index, right? They are used to make decisions. As Arvind Naranian has pointed out, this can be textbook horrible, right? As in this app by HireVue, an example of AI whose only conceivable purpose is to perpetuate societal biases. So pay with your face, indeed. And those are just the thoughtless, deliberate uses or misuses of these automation techniques. Let's not forget about the thoughtless, implicit biases built into seemingly everyday imaging systems in which algorithms literally don't see you. If you know this wonderful example of a Hewlett-Packard computer that's unable to see this fellow here. Or algorithms which see you in a way which is nauseatingly offensive. So how does this happen? This is not just an engineering problem. Engineering can help, but it can't fix it alone. It happens on an individual level. It happens on an institutional level. And as Zeynep Tufekci has remarked, we are building the infrastructure for a new kind of authoritarianism. But it doesn't have to be this way. As Hannah Arendt has remarked, the most evil is done by people who never make up their minds to be good or evil. And as Edmund Burke has remarked, similarly, the only thing necessary for the triumph of evil is for good men to do nothing. It follows that if your motto is don't be evil, you actually have to do something. Well, repairing bias, dismantling patriarchy and capitalist white kyriarchy, and building a just and better world is a large and sprawling problem. I can't even begin to start, but in my remaining time, I'd like to focus briefly on just one tiny, partial, but very cost-effective solution, which is the one I happen to know about best, which is to find a way to integrate artists, especially artists who are skilled at making software, which is increasingly common, into your research communities. So I'm a conduit here for recommendations from some great minds who've come before me, starting with Stuart Brand, who has discussed why artists were integrated into the Media Lab. For example, to be cognitive pioneers, exploring the recently possible, to keep things culturally relevant, and to keep high standards of presentational craft. One of my mentors, Michael Neymark, offers that artists stimulate a research community, act as magnets to bring together unusual teams, and provide content to test tools. Also, that he goes on, that new media projects can be a means for collecting valuable data. Google QuickDraw is an excellent example. That they may prompt other researchers down unexpected paths and keep researchers street smart through public scrutiny. Leah Beakley has pointed out that artists bring cognitive diversity. They think in ways which are concrete rather than abstract. They work in ways which are improvisational rather than planned. And they strive to make things which are expressive rather than utilitarian. Artists have often developed special life skills, which, to be perfectly honest, may have gone soft for folks in wealthy corporate environments. My graduate thesis advisor, John Maida, has pointed out that artists are accustomed to innovating with extremely constrained resources, dealing comfortably with ambiguous, multivalent, and contradictory perspectives, and dealing with adversity and volatility. But finally, and my talk concludes here, consider bringing artists into your research environment because they can bring criticality to environments that are otherwise highly susceptible to techno-optimism and technophilia. This criticality can help predict shots from the outside. Maybe you shouldn't do that. What you might call ethical rubber ducking, understanding the social implications of technologies before your engineers do. Thank you.
All right.